So today we'll be deriving the governing equations for liquid heights in two tanks. So to get started, I'm going to draw these out as a representation. So we have tank 1, and we'll have tank 2. And they'll each have a height of, one will have height of H1 and the other will have a height of H2. And so we have a liquid flow that is called Q1 that goes into tank 1, represent that, and then from tank 1 into tank 2 we have a flow called Q12, and then out of tank 2 we have a flow called Q2. So with that, we're given that the flow rate of 1,2, which is Q12, equals alpha 1 times square root of H1 minus H2, which is the height, and then Q2, which is the flow rate 2, equals alpha 2 times square root of H2, which is the height of 2. And we know that the density is going to be constant. And so with that, we're going to find the volume, which would be tank 1, which would be tank 1 volume is equal to area of tank 1 times H1, which is the height of H1. So with that, we're going to do the rate of change of the volume. And so we'll have an equation that looks like the derivative of area 1 times H1, which is the volume, over dt, which is change in time, equals flow 1 minus flow 1,2. And so we know that the area is going to be constant, so we can go ahead and take that out of the derivative, and we're going to divide by it on the right side. And so we're going to take tank 2 now, and we can do the same thing. So we're going to have, instead though, we'll have Q12 going in and Q2 going out or exiting. And so those are the flow rates. And so we'll have dA2 times H2 over dt equals Q12, flow rate 1,2, minus flow 2. And again, area is constant, so we can take that out of the derivative. We can divide and say that it's divided by area 2. And so now in the original equation, we're given that A1 is equal to 1 meter squared, and we're given that alpha 1 equals 0.5. We're given that A2 equals 1.5 meters squared. We're given that alpha 2 equals 0.25. And then we're also given the initial heights of the tanks. And so we're given that for height 1, or for tank 1, we're given that the height 1 equals 2.0 meters, and tank 2, the initial height, equals 1.5 meters. And so with that, now we're going to go ahead and we're going to plug this information into Python Collaboratory, and we're going to get a plot that represents this flow. So after just deriving those governing equations by hand, now we're going to use Google Colab to create a plot representing this flow. And so first we're going to set up this coding by first putting some initial conditions stuff. So we're going to do from skippy.integrate. And so this is all just stuff to help us be able to run our code. Or import solve underscore IVP, and then we're going to say import numpy as NP, make things shorter. We're going to say from skippy dot interpolate. I have a feeling I'm going to spell things wrong throughout this. Enter P1D. And then we're also going to say from, since we're plotting, from plotly.subplots import make underscore subplots. Everything looks right so far. And the last thing, we're going to import plotly.io as pio. And so from there, we're going to go ahead and we're going to define what we have. So we're going to say definition of dh dt of t comma y. Let me say that look, we're getting a class announcement, but unfortunately we don't have that today. We're going to say that h1 equals y bracket, and then we're going to say that's 0, and then we're going to go enter. Oh no, we got to bring that back, and then we'll go outside that and we'll say that h2 will equal y bracket 1, and then we'll say that q12 equals alpha, and I put a random j in there, alpha 1 times numpy dot square root of h1 minus h2 and then we'll say that q2 equals alpha 2, let's see, where's times numpy, and oh, I capitalized that by accident, I have my caps lock on, numpy dot square root of just h2 this time. That's what we wrote out before. And then we're going to say that dh1 equals qn, my bad, qn times of t, of time, minus q12, all divided by a1, just area 1. And we're going to say that dh2 equals q12, so that's the flow 12 minus flow 2 divided by a2. And so from there, we're going to return, say bracket, we're going to return dh1 comma dh2. It'd help if I could close that correctly. And then from there, we're going to go ahead and we're going to put in more of our given values. So we know that alpha 1 was equal to 0.5. We know that alpha 2 is equal to 0.25. We were given that A1, area 1, equals 1.0. We're given that area 2 equals 1.5. We were given that H initial, the H initials were, we had 2 meters for tank 1, and then we had 1.5 meters for tank 2, and then the time we're calculating it for is 100 seconds, so we're going to say that's equal to 100.0, and then we're going to go ahead and we're going to say that the Q in volume is going to be equal to, we're going to go 1 meter cubed, go 1.5 meter cubed. Oh, shouldn't put the M in there, that'll mess it up. And then 1.5 will end it. And then another class popped up again. And then we'll say that Q in for the time is equal to, we're going to start, of course, at 0.0. And then we'll say at 50 seconds, because that's when it moves from 1 to 1.5. And then we'll end with it at 10, which is the 100 seconds. And so we'll close that. And then we'll go ahead and say that Q in is equal to, we're going to do enter, then we'll put the quotes, and we will say that qn underscore t, comma, qn underscore v, and we'll say the kind equals previous, and then close that. And then we'll go ahead and we'll say that res equals solve underscore IVP, and that will be with DH DT, comma, 0, I keep typing O, 10, we'll close that, H initial, comma, method, and do redo. Let's see, I put wrong thing, I need asterisk, not a quote. Let's see, and there we go. And we'll go comma, dent, output equals true. Make sure I got everything right. Spelling looks good so far. And then we'll say that T is equal to numpy len space, and then that'll be from 0 to 10 to 100. And then we'll say that solve, we'll say equals res, put a space there, just keep it consistent, res dot sol of t, which is time. And now we're going to set up our figure. So I'm going to put in some lines of code for setting up the graph that's going to be made. So we'll say that fig equals make underscore subplot, and then we'll say that rows equals 1 and columns equal 1. Close that, and I don't need that sign. And then we'll say that fig, we're going to add to the figure, fig add, I put 2 G's by accident. And this is why I need to get better at typing. Fig scatter, let's see, scatter. And so we'll say that x equals t, y equals sol, we'll start at 0, and then we'll say that name equals h1, and then we'll say that we'll add also, let's see, we'll add scatter plot for, say, x equals t again. This time we'll say that y sol of 1, and we'll name this one is equal to h2. And then from there we're going to say we're going to update it, and so we'll say fig update layout, and then we'll dictate that, and we'll say that the width is equal to 500, and that the height is equal to 400, and this will just make it easier to view our graph. And then we'll go ahead and we'll say that legend orientation, so I'm still setting up the figure, equals h. We'll say that legend underscore x, we'll say that that's 0.5 increments, and we will then say that the legend of the x anchor, we'll center it, make sure I got that right, yep, center, and then we will say that legend underscore y, we'll have that of increments of negative 0.2, and we'll say that we'll title the x-axis title, and that will be our time, and so the title in there, so that will be equal to time, and we have that in seconds. And then our y title, so y-axis title, we'll say that that is h1 comma h2 because that is our heights. And then we'll add that our y-axis underscore show grid, we're going to want a grid so it's easier to view. Show grid. And then we'll make that true so that it pops up. And then we'll say that x-axis, and then we'll put tick marks in. And we'll say that equals 10, so every 10 spaces we'll have a tick mark. And then our final, we'll put our title in for the entire thing, and we'll call it what our assignment was, which is 2 tanks in series simulation. We'll go ahead and close that, put a comma in title, we'll space 0.5. Missing, that has to be title underscore, my bad. We'll say that that is 0.5. Then we can go ahead and close that. And then we're going to say template, we're going to equal pio.templates. And just to make it easier to view, we're going to put it in Plotly dark, because the dark background is definitely easier to see than this lighter, and I definitely need to switch mine soon. And so with that, we have some extra parentheses there. We're going to say fig.show. And so after that, we're going to go ahead and we're going to hit run all, and we end up with this lovely looking graph to represent our flow and for our problem.